Okay, thanks. Wow, I'm really kind of surprised there's this many people. I'm going to start off with a warning for those of you who are thinking that you might be able to attack other people using what I'm going to talk about. I have yet to figure out a black hat method, black hat use for this, because if you already own the IDSs, it's too late. You can get everything, and I'm only looking for the good things. What I'm talking on is passive auditing. We encountered a problem where I work where we have so many users that it became really difficult to find out what they're doing because nobody wanted to run a client or something, so we couldn't see what activity they were doing, were they patching, stuff like this. So we started developing signatures that actually kind of takes that out and actually eliminates the need for us to actually run a client on the end users. And so that's what I'm going to talk about here is what the signatures are, the sort of things you can find out in signatures, just by watching the network passively. So of course, brief introduction, why you need to audit. It identifies assets, so that when you get your alerts going through, if there's an attack on IIS, do you really care if it hit an Apache box? An inventory of what you have, where you have it, all that other good stuff. The state of auditing today, basically it relies a lot on active scanning. It uses a heavy usage of clients, so you need to have a client on that end machine. You connect to that client, it runs a scan, tells you what's on the box. And it's difficult or impossible in a decentralized environment. I work at a major university. We have 3 Class B addresses and about a dozen Class Cs. It becomes really kind of difficult in that environment, especially since most of them don't like us. What we're doing with passive auditing is we're using packets on the network, stuff that they're doing anyways, to find out what their patch levels are, whether they're doing antivirus software, whether they're updating at all, what OSs are doing. It does not affect in-system logging. That's one of the great things about it is because we get a lot of complaints every time we do try to scan, because they complain ad nauseum about the amount of logs they get. My feeling is tough, but okay. Also, we get to take advantage of all those black hat scans that are coming through. When you're in a university, you frequently don't have firewalls, or you have very limited use of firewalls. So I can find out what ports are open without ever touching the box, because the traffic goes across my sensors. I've got it. It aids policy enforcement. Some people like policies, some people don't. Ultimately, what it comes down to is event correlation, and that's where it becomes a real pain in the ass. And when you're looking at that many hosts, if you want to keep track of what their patch level is, that's, every patch has its own little line in that database correlated to IP address or MAC. If you can get access to the ARP cache, it's a lot easier. So these are things that we can monitor passively. OS. OS updates, whether they're getting antivirus and firewalls and spyware updates. Network services. Are they using Telnet, FTP, whatever. Open ports. Service versions, network application versions, that's more banner grabbing, though if you really get into it, there are ways of telling without actually grabbing banners, and policies. The downsides of this is, well, it's labor intensive, it takes up a lot of disk space, it takes a lot of time to build the big picture that you need, because you will not get it in the first week. In fact, you probably won't get it in the first couple months. You have to start really accumulating data before you know what's happening. It takes a lot of data. It requires a commitment of time and money, and that's not always something that works out well. If everybody's saying, well, we need to know this data now, go buy a scanner, hope that you get to the firewalls. If you are willing to actually take the time, you'll get a better picture, you'll get a different picture than if you do scanning. Can be bypassed. If people manually download stuff to one machine and they copy off that patch, I'm not going to see it. Though you can't bypass all this stuff. You go back to that OS stuff, as long as they want to talk on the network, I can find out what they've got. It actually benefits from an ugly network. It's one of those few places that not having firewalls really helps, because I can see so much traffic. So I'm going to start off with some rules. I wanted to jump right into the rules because I've only got 20 minutes here. So here's a basic snort rule. Try to keep these all nice and easy, very little stuff done with in bin hex. In hex. I'm just looking at the strings here, with a couple exceptions. So this first one, it looks for people actually updating antivirus information. Antivirus actually and firewalls, because that's with the Semantic Corporate Edition. You notice here you see the user agent. User agents are your friend if you want to do this, because they really come in handy. Everybody wants to advertise what they've got. Well, this is where you get them in handy. So you capture on this. You capture on that user agent. You can capture on the host, because they actually semantic sense everything to one place. Not everybody does that, so you have to watch that. Then right down here, that last line, you have that threshold, type limit, track. So what we're going to do is we're going to look at type limit, track by source. So each source IP address, count 1. So we only need 1 packet here to find out this is working. And we only record this on that one, 180 seconds. Sorry, 1800 seconds. The reason I had to do this with this particular rule is that it will go and do that so many times for so many different things. It was filling up logs. All I need to know is they did it. I don't need to know how many times they did it. And this is what the sort of traffic you get out of this is. If you notice that when you get down to the data, it tells you right in that line what they're updating. Semantic, antivirus, corporate, client, NT 9.0, English, so it's language, you have everything there. So by that, those 20s are of course going to be the space characters. That's what they're using there. So another rule. This is an OS update. We're looking for a specific Windows update here. I wrote a rule that just looks for the KB article. If you're actually really quick, they actually release the article numbers before they release the patches, but you have to know where to find them on Microsoft site. I didn't include that in the slide, which I should have. And so you can get a slight jump. Now, actually, I really recommend using generic rules that will catch everything and post-processing. I'm really big on post-processing. It speeds up the whole process from a machine point. And so what we're looking for has that string that says the get space, and that's a slash character. For some reason, well, this is me. I like using hex in those points. And you give a depth of 5. So this has to be in the first 5 first 5 characters coming from that host in the TCP field level. So then you're looking for the knowledge base article, and you want this line to end off with the exe, basically the get. This is the whole get string. These are elements out of it. One of these days I'm going to get around to rewriting these in PCRE so that they're per-compatible regular expressions, make the whole line a little easier to read. However, there's a penalty hit there, and I haven't quite figured out if it's going to be something I can keep up with. So out of this, we then find out it's a Windows ME host, because it's right there in that string that it actually downloaded. So you say MS download, update, version, capital. You get down there, it's Windows ME, knowledge base article, and this is also an English box. So this is all the stuff you see in their files that they're downloading from Microsoft. Also, this progressive download there, that's the user agent for ME, when you do the automatic update through them. Next rule, Windows malicious software removal tool, their new anti-spyware stuff. Again, this is a rule using similar functionalities to the last one. Right now we're going with the Microsoft bits for the agent. That is the normal XP 2000 agent that you're going to see. And this is what you see here. You see this packet come through. For this one, I actually, just in case anybody's curious, this one was TCP show I used to grab these packets out. I've also written some scripts for just extracting text from TCP dump files, your PCAPs. So you find out this is Windows. It doesn't really specify which one. Knowledge base article, name of the program and everything, again, English. Now this is where it starts getting a little more fun. Now with Red Hat, you tend to see a lot of people using their automatic update, the up-to-date stuff. This one is just checking in. It's saying, are there any updates available? This really answer questions about OSs also. Because all of a sudden you don't know just that it's a Linux box, you know it's Red Hat. So you get this whole string. The header info file is the one that actually says what is the differences between now and what I have and what is available. So you're going to see this one anytime it checks in, whether it gets a download or not. So this actually allows you to actually map out who is trying to be a good network citizen. And here's what you get. But if you look at the get string on this one, you see the pub, Fedora, Linux, Core 3, so you know they're running Core 3, and i386, so you now see you have an idea of the architecture, though there's a better one for that one, the next right up. And you see they're using the Red Hat applet. Now you can actually rewrite these so that you can download, check anything. You got to draw a line here. Where is the privacy? You don't want to actually be capturing everything they do, but you also have to say, this is the information we need to know to protect the network. And that is the biggest problem we've had, is actually where do you draw that line. Now this is another update. Looking for actually I rewrote this one early this morning, I messed up. It's not a check-in anymore. You're actually looking for the actual downloading of the update. Well, when you get to this one, hold it. What happened to my slide here? Crap. Okay, well, I'll tell you what that one did download. It actually saw the kernel. And when you see the kernel goes by, you get to see the architecture at a different level. You get to see it as i686. You get to see the language. You get to see the specific kernel version. So once you take this stuff out, you post-process it, you can actually find out a lot of stuff in that one kernel, in that one GET request about the box. Actually, I'm going a lot faster than I thought I would. So I should include more rules. So this is the check-in again. Okay, now this is where it gets a little more obscure. This top one here, all this snort signature does is it catches one SYN for each host every half hour. It just tapes a pcap dump of this stuff. I use this one actually to map OSs because I can take the pcap file, post-process it through P0F, and all of a sudden you have a list of every IP address and what it's talking and what the OS is. Now I have this every half hour. You will start encountering problems when you get to VMware or they're running NAT boxes. This is where that ARP cache comes in. Using that ARP cache, if you have access to the ARP table, you can say at this point, was it the same MAC address as the one that was there before? So you can say if it's two different MAC addresses, it's probably two different machines. However, if you have the same MAC address, you're now looking at VMware or NATing. If you go and look at the MAC address, you can probably tell if it is a Linksys little router or if it is actually a Dell box, in which case it's VMware. So it's actually all about collecting so much data that you can actually then make logical choices about what's happening on the net, about the hosts themselves. The second one here is the ability to actually map what services they're doing. This one actually uses banner grabbing. There's also some signatures for doing like what versions of SSH they're running. And when you actually get down to versions, that becomes really important because you actually can say, hey, there's a vulnerable version here, and you can actually notify people, say, you need to fix this. You never had to scan the box. You just watched them doing their traffic on their own. So in that one, you're looking for basically the server return field from the server. This is one of the places where you can start mapping out what's happening on your host that aren't them doing things, it's people coming into them. So this here we're looking at Microsoft IIS 5.1. That version actually only exists in XP. So you know that they're running XP also. This can be spoofed, of course, with Apache. You can compile it with any browser, with any server. You can actually compile this stuff in and change it. I say any, and that's actually an overstatement. But the idea is that the people who are really trying to do that stuff, these are people who are good admins anyways, and I'm not worried about them. I'm worried about the idiot who runs their box. They have never patched it. They just put it up on the network, and 5 minutes later, it's a Warehouse box and it's attacking 30 million other hosts. That's my issue. I don't care about the person who's actually sitting there doing their job. It's all the ones that aren't doing the job that I'm trying to find with this. This also gets by the biggest problem that we had on campus really was dealing with firewalls. Windows SP2 came out, all these firewalls. All of a sudden, we can't get into these boxes with the scanners we do have. If you want to write a rule that will allow an IP address to talk to a box like that, you actually end up writing 65,535 TCP rules, 65,535 UDP rules, because they don't actually allow you to set a trusted IP. Microsoft's firewall does not have that concept. It's trusted ports, trusted programs, that's it. This way, we don't have to worry about that. We actually see the patching. We don't have to do the vulnerabilities yet. Scanning is still great. Scanning will help you a lot. It will answer questions faster than this will. But in the long run, you get a different picture here. Because if you look at those, like the user agent stuff, you can see, are they running Kazaa? Are they using, Outlook? You can see all this stuff by looking at the traffic that comes out of this box. Things that you will never see. You can't tell what browser somebody's using by a scanner. Are they running a 3-year-old version of IE? I got a break-in yesterday, actually 2 days ago, on campus. They were running a version of IE that had a flaw in it that was fixed 2 years ago. Now all of a sudden they've got whole batch of extra stuff on their computer they didn't know about. This I can tell. I mean, by actually watching the GET request that comes out of that box, how they request things, because that's also in there. I mean, when you say you're going to get the, download this, if I go back a couple screens, that's where you, let's see, that user agent comes in, because the user agent is it's not required. You don't see this in Debian. When it does patching, it doesn't do this. Actually, I didn't include all I have a lot of signatures for this. I didn't include all of them, but I have patches for SUSE, Debian, Mandrake, all these things. These are all available out there. The information is available. The hardest one I actually had to come up with was one for Solaris, because if you look at like Solaris 10, this automatic update feature, it encrypts the whole channel. However, when you look at an SSL certificate, when you do that key exchange at the beginning, and it sends what the certificate is, there's a place in there where it says who bought the license and what machine it goes on. Well, it just so happens that Sun, that machine is like Sun update. It's like Solaris update.sun.com or something like that. So you find that string, you know what's happening. You know they're now being a good network citizen. You don't know what patches they grabbed. And I'm sorry that I haven't figured out a way to get around the SSL. And if anybody has any ideas, come and talk to me. We got a lot of other things we can do with that one. I won't have to go back to work on Monday. So I can't get around that one, but I can help, give you an idea of who is actually helping on the network, who's being good. Got a question? What was that? Yeah, using statistic analysis, you actually could do that. There's a program I'm going to mention at the end. It's a different IDS system called Bro. It's kind of I refer to it as a bastard stepchild out of LBNL, but actually they love it and they use it a lot. It is written by Vern Paxton, and it does some great anomaly detection, but it also keeps a connection log that says this IP address on this port talked to this IP on this port, this is how much traffic went by, and this is what time it happened, and how long it took. Using that, you can go back and do the statistical analysis and actually get a good idea of did they download one patch or did they update the whole system. I really didn't think I'd go through this fast. So on here. So these are the tools that I use for doing this. Snort. I'm a big Snort fan. It's easy. You can really get into it, and it's really fairly powerful if you get into it. P0F. That OS fingerprinting that I do, post-processing it through there, it helps a lot. Make sure you do have one of the latest versions, because the one I first installed, it didn't give me a timestamp. It just kind of said relative to when I started running P0F. It didn't really help me identify. When you have to go back to that ARP table to figure it out, you need that timestamp. So make sure you have the latest one. TCP dump. I use TCP dump for everything. I'm sure everybody here does. Got a question? Yeah? Actually, our network group on campus, they actually have a database that they keep of it. They dump the ARP cache from every switch and every router on campus every 15 minutes. So we go back to the database. What was that? Too many years of punk concerts. I'm really going to... Do I have a suggestion? Fortunately, I don't. It's just not something I've had to encounter yet, and I haven't had to figure out how to do it. Yes. Oh, okay. TCP show and ngrep. Those are tools that actually will help you pull out those strings. Now, actually, TCP show has one flaw in that it doesn't give you an accurate time. It actually doesn't dump the time in a format that I could use well. And ngrep does that, however, it core dumped on large files. So I wrote my own. It really is just a simple Perl script. If you think about it, you pull out the Perl, you actually, if you wrap you do the minus lowercase x with TCP dump, it gives you that whole binary, it gives you the hex actually. Well, you can just process through it, measure out, okay, this is the IP header, this is the TCP header, and now you want the data after that. So actually on the website that will give you, I have that script. It's really actually a very simple script. And so I use, that's where I go back to, I use TCP dump more than anything else. And Perl. Perl is great. Now I mentioned that Bro IDS. If you are interested in that, it's a really great IDS system. Awesome anomaly detection. Really kind of hard to use though. I mean, be prepared. But it's bro-ids.org. It is a really good one. It's just, and it will never compile into Windows, so don't even try if you're running Windows. A lot of custom scripts. You really have to be able to write your own programs to do this stuff. At least for now. I'm hoping that eventually I'll get enough of them that I can just hand them off to people and say, hey, use this. But for now, no, you're going to want to write some of your own. I have some example scripts that I use, so if you want them, they'll be on the website. They should be on your CD, though I've updated all of them. So go to the website. And a database. At the end of the day, you are going to need a database more than you're going to need anything else that I talk about. Because if you figure that Microsoft has released about 35 major patches this year already, those are the major, the MS-05, they've already released like 35, and this is actually kind of a slow year for them. And you look at like 40,000 hosts, and then you look at all the antivirus programs, and then you look at all the OSs they're running, you need a database. I mean, I've been doing actually for a while with ngrep. Well, not ngrep, fgrep. So I just grep out flat files, and we're building the database now. I had to prove that it could be done before they built, and then somebody would take the time to build a database for me. So at the end of the day, though, you are going to need a database to do this. So I'm going to say thank you for coming. Got an address there. If you go to www.passiveaudit.org, you'll see all the scripts I have, all the signatures. And I really would like to actually have more people writing signatures than just me. I do this at home at like 3 o'clock in the morning. So help. This is how and when I have time, I do this because I find it fun. I'm kind of curious, how far can I go? Can I actually, I can actually find out if they've got Office and stuff, but how much can I learn about the computer? I don't want to let anybody think that I'm actually trying to learn out stuff about the people. That'd be wrong. At least I would on campus. Okay, thank you. I'll be outside if anybody wants to get questions or wants to volunteer. Okay. Actually, I was going to try to drive them over to the bar if there weren't that many people. Priorities.
All right. Thank you. We need everyone out those doors there.